Praise the Lord. Hello everybody. Welcome you all. In this session of the video class, let us cover all the exercise problems. From the first exercise, that is exercise 5.1 from the chapter of complex numbers for first PUC science students. Hope you don't need any introduction for this. Believing that you have already gone through the basic concepts, let us go through the exercise question. So this is what the general question is. Express each of the complex numbers given in the exercises 1 to 10. That is, first 10 questions you have to express in the form of a plus ib. Okay, so first question is already given, 5i into minus 3 by 5 of I. Let us express this in the form of a plus ib. We all know that a complex number is a number where it can be expressed in the form of a plus ib, where a and b are integers and I is equal to root of minus 1. So the first question is a very simple one. Not much calculation is required. If I take down the given number, I have 5i into minus 3 by 5 into I. So this can be written as, if you multiply this 5 and 5 gets cancels, you have minus 3 into, you have I into I, that is I square. Okay, so this can be further written as minus 3 into, we know I square is nothing but minus 1, because don't forget this, we know I is equal to root of minus 1. This is the standard result which you have to know, particularly when it comes to complex numbers. Is it clear? So since I is equal to root of minus 1, I square will be minus 1. So this will be minus 3 into minus 1 will be 3. So if you have to write it in the form of a plus ib, so this can be written as 3 plus I into, it is just a real term, imaginary term is 0. So this is nothing but 3 plus I into 0, which is the required a plus ib form. Moving on to the second simple question, you have I power 9 plus I power 19. Okay, so the simplest form is nothing but try to write in this in the form of 4n plus 1 or 4n plus, okay, multiples of 4. So you can write it as 4 2s are 8 plus 1. That will give you 9. Similarly, plus I into, this is also can be written as, this is 4 4s are 16. So it is 4 4s are 16 plus 3. That will give you 19, isn't it? So now we know that whatever is in multiples of 4, purely that will be nullified. You just have I power 1 and plus this is nothing but I power 3. Okay, so this would, you can write it as I power 1 would be I, and coming to I cube, we know I cube can be written as what? I square into I, isn't it? And we know I square is minus 1 and this is I. So finally I can write it as I minus 1 into I is I. So this is nothing but 0. So this term is purely 0. So if you want to write it this, how can you write 0 in a plus ib form? Definitely it can be written, you just write 0 plus I into 0. That means the real part is also 0. The imaginary part will also be 0. Okay, very simple one. Fine. Let's go to the third question. Moving on to the third question, we have a simple result, I power minus 39. Now what I'm going to do it is, I will write this minus 39 as minus of 40 plus 1. You can write it, isn't it? Because minus 40 plus 1 is minus 39. And this can be written as, look here, 4 times minus 10. Are you following? So 4 times minus 10 is 40 plus 1. Okay, so this is of the form I power 4n plus 1. We know our I power 4k plus 1 will be simply I, isn't it? So I can directly write this as I, okay, because minus 10 will belong to integer which is z. Okay, so this I can be written as 0 plus I into 1. This is my required a plus ib form. Is it clear? Okay, so let's go on to the question number 4. Moving on to the fourth question, we have 3 into 7 plus I into 7 plus I into 7 plus I into 7. So let us expand. This is nothing but 3 sevens are 21 plus. Now I into 7, I will be an imaginary term. 7 threes are, that will again be 21. Okay. Plus, now look here, I into 7 will give me I into 7 or 7I. Okay. Plus, be careful. Now I into I will give me I square. That is nothing but 7I square. Is it clear? Now this is nothing but, now look here, I will write it as 21 plus. Now what is 21I plus 7I? If you add up, you can write it as 28I, because these both are imaginary terms. Now look here, we know I square is minus 1, so I can replace I square by minus 1. So this I will have 21 minus 7. Okay, so this is actually 21 minus 7 will be the real part, plus 28I. Okay, so this is nothing but, what is 21 minus 7? 14, isn't it? So I can write it as 14, that is A plus I into B. So this is my required A plus IB form. Okay, these are all 1 mark questions. You don't need much intelligence to solve this. Only thing is, you should know the concept of the complex numbers. That too, the basic ones. Okay, yeah, let's go on to question number 5. Here comes the question. You have 1 minus I minus of minus 1 plus I into 6. Let us expand. So you can write this as it is, 1 minus I, minus of minus becomes plus 1, and minus into plus will be minus. I into 6 is as it is, I into 6, or you can write it as 6I, both are same. So this will be nothing but, you can see here, real terms are 1 plus 1, group it if you want. Okay, now you have both the terms are minus, so minus I minus 6I. Okay, so this can write it as, this can be written as 1 plus 1, that is 2, and minus I minus 6I is nothing but minus 7I. Okay, now he has asked you to write it in A plus IB form. Please don't leave it here. You can write this again as A plus I, which should always be plus I, and if you have a negative sign here, take it inside. So the required A plus IB for the given complex number is 2 plus I into minus 7. Is it clear? A very simple question. This is our question number 6. We have 1 by 5 plus I into 2 by 5 minus 4 plus I into 5 by 2. Let us remove the brackets. You have 1 by 5 plus I into 2 by 5. Okay, minus 4 plus into minus is minus I into 5 by 2. Let us separate the real terms and imaginary terms. So you have 1 by 5 minus 4 will be a real parts, plus I into the imaginary part would be 2 by 5 minus 5 by 2. Let us simplify this. So this is nothing but, if you take the LCM here, you will get LCM as 5, and this remains as 1, and this is cross multiply, 5 fours are 20, plus I will remain as it is. The LCM of 5 and 2 would give me 10. So that means you have to cross multiply. 2 into 2 will give me 4, minus 5 into 5 will give me 25. So here comes our final result. 1 minus 20 is nothing but minus 19 by 5 is the real part, plus I into B. What is 4 minus 25? This will give me minus 21 by 10. Okay, so minus 21 by 10, which is the imaginary part, and this is our complete A plus IB form. Moving on to question number 8. It looks quite simple, but it takes some calculation here. So this is nothing but, I have 1 minus I whole power 4. See how it's up to you how you're going to simplify. I feel this method is simple. So I'm going to take this as 1 minus I square whole square. Okay, so this is nothing but, now inside term I will use A minus B whole square. So this is A square plus B square minus 2A into B. Is it clear? Outside I have a square. So this will give me, we know 1 square is 1, and we all know again I square will give me minus I. Please be careful. So this is nothing but minus 2 into 1 is 2I. Is it clear? Don't forget you have a square outside. Now 1 minus 1 gets cancels. You are just left over with minus 2 into I square. So this is nothing but, because it is square, minus will go off. 2 square will give me 4 and I will give me I square. Okay, so this is nothing but 4 into, don't forget, again I square is minus 1. I need not write it every time I square is equal to minus 1. So this is completely my real term. So the a plus ib form is nothing but minus 4 plus I into 0, because the imaginary part is not present. Is it clear? So this is the final answer for this question. So this will be the question number 7. Looks quite complicated. Let us solve it. Don't have any other option other than solving. Let us remove the bracket. You have 1 by 3 plus I into 7 by 3. Okay. Next, plus 4. Since it is positive term outside, I need not worry. I can take it as it is. So it is I into 7 by 3, I into 1 by 3. Now check this. Minus of minus will give me plus 4 divided by 3. Okay. Now plus into minus will give me minus 1 into I is I. Okay. So separate all the real and imaginary parts. So real part here I have is 1 by 3 plus 4 plus 4 divided by 3. Okay. Plus I into the term I have here is 7 by 3 plus 1 by 3 minus 1. Is it clear? Fine. So let's take the LCM now. So this is nothing but, here all the terms, the LCM would be 3. So this will give me 1 and this 3 will be multiplied here. So 4 3s will give me 12 plus 4 will replace as it is. Plus I into, again here the denominator is 3. So this will remain 7, this will remain 1 and 3 will be multiplied to this. So 1 3 is a 3. Okay, fine. So this is nothing but, we have almost arrived to the final answer. 12 plus 4 is 16 plus 1 will give me 17 by 3, which is the real part, plus I into, now 7 plus 1 will give me 8. 8 minus 3 will give me 5. So I into 5 by 3. So this is my required A plus IB form. Fine. Hope you don't have any confusions in this. Let's go on to the next question. So the next question we have is 1 by 3 plus 3I whole cube. Now this looks like A plus B whole cube formula. Does anyone know what is the formula? Do you remember? Well, fine. So this would be the formula. It is A cube plus 3A square B plus 3A into B square plus B cube. So using this, we are going to use this formula to solve this question. So this can be further simplified as using the formula 1 by 3 cube, okay, plus 3A square, that is 1 by 3 square into 3A square B. B will give me 3I, okay, plus 3AB square. A means 1 by 3. B square will give me 3I square. Finally, 3I cube. Are you following? Fine. So this is nothing but 1 divided by 3 cube will give me 27. So 1 by 27. Now, please check it. You have, okay, let me take it directly. 3 into 3, that is 9I divided by 3 square. Are you following? 3 square, that is nothing but again 9. Now again, plus, if you want, you can cancel this as it is here only. I'm just left over with 3I whole square. So 3 is nothing but 3 square is 9 and this is I square. Okay. Finally, plus again 3 cube would be 27. Don't forget this is I cube. I into cube is I cube. So this would be nothing but 1 divided by 27, a fraction. Now 9 and 9 gets cancels. So this will give me plus I, simply I. Okay. Now plus 9 into, we all know I square is minus 1. Okay. Now plus 27 into what is I cube? We know I cube will be nothing but minus I. Is it clear? Because I cube is I square into I. I square is minus 1. That will give me minus I. Isn't it? So now let us separate the real and imaginary terms here. You have 1 divided by 27 as the real term. So this is again with the real term, that is minus of 9. Now coming to the imaginary terms, I is there. So if I take I outside, I'll get 1. And this is minus 27, which is taken separately. Is it fine? So this is nothing but, so here you may have to take the LCM. This will give me 27. So here this one remains as it is, minus 27 nines. You can use your calculator. You will get 243. Yeah, you can check it out because you are allowed to use a basic calculator. Now plus I into, no doubt here, 1 minus 27 will give me minus 26. So the final answer for this question would be, let me write it here. So it is minus 242 divided by 27, okay, plus I into minus 26. This will be my final A plus IB form. This concludes the solution for this question. Okay, so we have one more question to write it in the form of A plus IB. Let's take that. Here comes the question number 10. Minus 2 minus 1 by 3i or I by 3 whole cube. Now you can see here, before expanding, both the terms I have minus. If I take minus common, you have plus 2 plus I can take this as I by 3 whole cube. Okay, so this is nothing but, remember, because the power is odd, the minus will remain as it is, and I can write this as 2 plus I by 3 whole cube. Are you following? Now let me keep this minus outside and use my A plus IB formula as I've used it in the previous problem. Okay, so this will give me A cube plus 3 A square into B. B is I by 3. Okay, fine. Plus 3 A into B square, that is I by 3 square, plus B cube, that is nothing but I by 3 cube. Fine. This is nothing but, don't forget, you have to carry this minus for every step. Now 2 cube would be 4 2s are 8. Okay, fine. Now this, if you want, you can cancel this 3 and 3 here. So this will give me plus 2 square would give me 4i. Now fine. So this is nothing but plus, this is 3 2s are 6, isn't it? 6 what is this will give me I square, okay, divided by, this is actually 9 because it is 3 square. Okay, fine. Plus I can take this as I cube divided by 3 cube is nothing but 27. Don't forget there is a minus outside, so minus of, I can further write this as 8, okay, plus 4i. Now we know this is 3 2s are and 3 3s are, and we again know I square is nothing but minus 1. Okay, plus again 1 by 27, let me keep it as it is. I cube is again, as I told you here, this is minus I. Okay, so this is nothing but, if I keep this minus outside, compare the real and imaginary parts. So you have 8 minus 2 by 3. Okay, now in the imaginary parts is plus I into, it is 4 minus 1 by 27. Is it clear? Now if you further simplify, minus is taken outside, take the LCM, it is 8 3s are 24 minus 2. So what is 24 minus 2? So you will give 22 divided by 3. Okay, plus I into, again if you take the LCM here, denominator would be 27. Now 27 4s will give me 108. 108 minus 1 would give me 107 inside. Is it clear? Now remember, there is minus term outside. So the final A plus IB form would be minus 22 by 3 would be my A, plus I into, this minus will again multiply here, minus 107 divided by 27. So this would be my final a plus ib form for the question number 10, isn't it? So hope you don't have any doubts in this question. If you have any doubts, then you have to think why you got any particular step I have written that way. If you think over the situation, you can easily understand. Okay, so let's go on to the next question. Okay, for the next three questions, the question is common. Find the multiplicative inverse of the following complex numbers. Okay, very important question. So whatever the given complex number is, it is better you take this as z, which is nothing but 4 minus 3i. If you want, you can take it as equation 1, no problems. Okay, what is multiplicative inverse? Multiplicative inverse. Actually, multiplicative inverse is nothing but z inverse. That is nothing but 1 by z. Don't forget. The multiplicative inverse of any complex number is nothing but the reciprocal of 1 by z. So that is nothing but 1 divided by 4 minus 3i. Okay. So how we are going to take this? We are going to solve it by the process of factorizing the denominator. So this is nothing but you multiply and divide by 4 plus 3i, its conjugate, that is 4 plus 3i and 4 plus 3i. Is it clear? Multiply and divide. Now look what happens to the next step. This is nothing but 1 into 4 plus 3i. It will remain it as 1 plus 4 plus 3i divided by, now look here, denominator looks of the form a plus b into a minus b. That is nothing but a square minus b square, that is 3i whole square. Okay, so this is nothing but 4 plus 3i divided by 4 fours will give me 16 minus 3, don't forget it is 3 square, that is 9 into you will get I square. Okay, so this is nothing but you have 4 plus 3i divided by 16 minus 9 into what is I square? I square is minus 1, isn't it? So this is nothing but 4 plus 3i divided by 16 minus of minus is plus 9. So this will give me my multiplicative inverse, which is nothing but I can split this as 4 divided by 16 plus 9 would give me 25 plus I into 3 divided by 25. Okay, so this is my multiplicative inverse, that is z inverse, multiplicative inverse of the given complex number. Okay, before I go on to this next question, there is also a hint for z inverse. Okay, direct formula, if you can remember, if z is equal to a plus ib, this implies z inverse, which is nothing but 1 by z would be a divided by it would actually be a minus ib, that is a divided by a square plus b square. Okay, next plus I into minus b divided by a square plus b square. That is what it would be. If you want, you can check it here. Is it clear? Fine. Okay, let's take the next question. I have z is, minus I is the given complex number. As I told you, let me take the given complex number as z, which is minus I. This will be my equation 1. Okay, therefore, what is multiplicative inverse? It is nothing but z inverse, which is nothing but 1 by z. That is nothing but you can take it as 1 divided by minus I. If you have minus, you can just multiply by I and divide by I. Clear? So this will give me 1 into I will give me I divided by minus of I into I is I square. Okay, so this is nothing but I divided by minus of, we know I square is nothing but minus 1. So this will be nothing but I divided by minus of, minus is nothing but plus 1. I by 1 is nothing but I. Okay, therefore z inverse, the multiplicative inverse is given by I. That is nothing but 0. If you write it in a plus ib form, 0 plus I into 1. Is it clear? And I want to give you another simple note, dear students. Please note it down. This would be very useful while you are solving the problem. If you have seen this, the value of 1 by I would be nothing but minus I. Is it clear? Since I took 1 by minus I got plus I. Okay, so that is taking the minus here. So you can either take 1 by I is equal to minus I, or you can remember anyhow you want, or 1 by minus I would be give you plus I. Is it clear? So that is the multiplicative inverse. Is it clear? Okay, so let's take the one more question left over to find the multiplicative inverse. Question number 12. Going on to question number 12, he has given the complex number. Let me take this as z is equal to root 5 plus 3 into I. I can take this as equation 1. Okay, therefore multiplicative inverse, as I told you, z inverse is 1 by z. So this is nothing but I'll take 1 divided by root 5 plus 3i. Okay, so this can be written as multiply and divide by root 5 minus 3i, its conjugate. So this is nothing but root 5 plus 3i into numerator is multiplied by root 5 minus 3i divided by root 5 minus 3i. So this will be nothing but numerator, it will remain as it is because it is 1 here. So root 5 minus 3i into 1 would give me root 5 minus 3i divided by, this looks of the form a plus b into a minus b. It will give me a square minus b square. This is nothing but 3i square. Okay, so this would give me, numerator does not change, root 5 minus 3i divided by square and root gets cancelled. This will give me 5. Okay, now minus 3 square would give me 9. Remember, I will directly write I square will give you minus 1. So this will give me, I have root 5 minus 3i divided by, this will give me 5 plus 9. So this is nothing but 14. Okay, so this can be written as, therefore z inverse. Z inverse is nothing but, I can write it as root 5 divided by 14 plus I into minus 3 divided by 14. Remember, don't keep this minus outside, you have to keep it inside if you want to take this as equation 2, which is my required multiplicative inverse of the given complex number. Is it fine? Okay. Okay friends, here comes the last question of the exercise as follows. Express the following expression in the form of a plus ib. This may look like a Dracula. Need not worry. It takes some calculation. Not all the problems will be a single mark question. This would be a 2 mark question. If you have to write it in a plus ib form, let me first consider the given complex number as z. Okay, it may look a very difficult question. Actually, this takes simple calculation. Look at the question now. Now this is 3 plus I root 5, 3 minus I root 5. This looks like a plus ib into a minus ib. We know that is nothing but a square minus b square, that is I root 5 whole square. See how easily it simplified. Now denominator, let me remove the brackets because it is simple addition and subtraction term. So that is root 3 plus, this is nothing but root 2i or I root 2, both are same, and remove the bracket, minus root 3, minus of minus will give me plus I root 2 as it is. So this will give me 3 square will give me nothing but 9 minus, let me take it as I square into root 5. I can directly write it as root 5 square will give me 5. Okay, need not expand this. Now here what happens, plus root 3 and minus root 3 gets cancels. So what is left over, I have I root 2 plus I root 2. This is 2 times I root 2, or I can write it as 2 root 2 into I. Is it clear? So this is nothing but, now see how I will try to simplify in a better way. So this is nothing but 9 minus 5 into, look here, this I square we know it is nothing but minus I divided by, this is nothing but 2 root 2. I'm going to just write it in a separate way by taking 1 by I separately. Okay, so this would be nothing but, this is 9 minus of minus will give me plus 5 divided by 2 root 2. Okay, into, just now I have told you 1 by I is nothing but minus I, isn't it? We have just proved I can take it directly because As I have already told you that I will use it as a formula. 1 by I is nothing but minus I. Is it clear? So I've used this result, and this is actually nothing but, what is 9 plus 5? This is 14 divided by 2 root 2 into minus I. Let us cancel. This is 2 once and 2 7 times. So this would be nothing but minus 7I divided by root 2. Isn't it? So this can be further written in a plus ib form. Is this is completely imaginary term, so real part is 0 plus I into imaginary part would be minus 7 divided by root 2. This would be my z, and this is my required a plus ib form. So this completes the final answer for this question, and also this completes all the question from the exercise of 5.1, which is the first exercise from the chapter of complex numbers. Dear students, hope you would have enjoyed this session. Your comments are always welcomed in the comment box, which would help us to do or serve you better than what we have done until now. Don't forget to like the video and share the video with all of your friends so that it can be useful even for them. Okay, then it's time to say bye for you. We'll meet again in the next session, where we are going to solve the second exercise, that is exercise 5.2, all the questions in the next video. Until then, take care of yourself. God bless you all. Bye.